This is a recap of the last tutorial, which was a monster, about 27 minutes long. I'm sorry for that, but Fourier analysis is just a monster. So I would still encourage you to go through it. This is just a quick recap, but I would still encourage you to go through that monster because I believe it is well done. I looked at it, checked it, and it's solid, so I would encourage you to go through it. But let's take a look at a recap. So here's the general idea behind Fourier analysis. You're given a function like this, some function that is stepwise. This thing it comes up, it shoots over, it comes straight down, and so it's a stepwise function that you would have a difficult time modeling mathematically. Joseph Fourier, genius mathematician from France, came up with this idea that that any function can be represented by a constant plus a combination of cosines and sines, given that you find these coefficients right here. And he derived these coefficients to be this, this, and this, right? Well, this coefficient, these are coefficients, and this is the constant. So he derived this constant, and then each of these are the coefficients. Okay, so the basic idea is to find these three things and then plug into this thing. Okay, so first thing is that we notice that this is an odd function, right? Because it comes down, over, and like this. Because this is an odd function, we model odd functions with odd functions. So we use odd functions to model odd functions. So the sinusoidal function is an odd function, the cosine function is an even function. So all of these cosine terms are going to be gone, right? So you're only going to need to solve for the b's. So on an exam, you need to make note right away, okay, is the piecewise function, this crazy bizarre thing, that I'm being asked to model, is this thing even or is this thing odd? Once you determine that, then you can determine which one of these you're going to be using, right? Okay. That will save you tons of time, and that will happen. I guarantee you. That's how professors do it, because it takes too much time. Otherwise, they have to do that because you can't finish it in an hour's time. Okay. So you go through and you find for this one we were just finding the b's. So we showed that the a's were 0. We found the b's by plugging into this formula. L is equal to pi. So we go through, we find b1. We go through, we find b2, b3, b4, and so on. And you can look at the tutorial for the guts of that. Okay. And then we noticed eventually that all of the even b's, all of the b2, b4, b6, b8, they were all equal to 0. So all we had to do was find the odd b's. And eventually we noticed a pattern. We noticed that for the 1 it was 4c over pi, and then for the 3 it was 4c over 3 pi, and then for the 5 it was 4c over 5 pi. So it was always 1 over n times 4c over pi, right? So now you can just write down a bunch of terms. You could write this here, if you look at this final thing here, if you come to here, you could just write 4c over pi times sine of x, 4c over 3 pi times sine of 3x, plus 4c over 5 pi times sine of 5x, plus 4c over 7 pi times sine of 7x, plus 4c over 9 pi times the sine of 9x, plus 4c over 11 pi times the sine of 11x, plus 4c over 13 pi times the sine of 13x, plus 4c over 15 pi times the sine of 15x, and so on. And you can write down a huge series to model this thing really closely, and you could do it just like that. Okay? Next thing, use your calculator. So you can set up integrals with an evaluate sign. So you can set it up to where you have 0 to pi cosine q times x dx, and then put a little evaluation bar, and then on the outside of the evaluation bar put q equals, and then you could put q equals, and you put a 1 in there, and then you bring it back into the editor and you change it to a 2, and then you bring it back into the editor and you change it to a 3. And so you can do that, and I did that just to verify that all the cosine terms would come out to be equal to 0. I just went through and did those, and you could do it for the sine also. So this is a very powerful tool to use to keep you from making careless errors, right? Okay, this is just a recap of the previous tutorial. I'm going to step out of the way and give you a clear screenshot.